This time we'll be looking at how we can determine the value of g, that is acceleration due to gravity, using simple harmonic motion. Most of the time, the value of g will be given as 10 meters per second square or 9.8 meters per second square. And this value of g can be determined in the laboratory. So one of the methods is using the principles of simple harmonic motion. This can be achieved when a small bulb of mass m is attached to an inextensible string, and the length of that string is assumed to be L. So using the period as the time taken for one complete oscillation when length is involved is 2 pi square root of L all over G. So by this case, what our interest here is G. So in trying to make G the subject of the formula, we square both sides of the equation. So that becomes t squared equal to 2 pi square root of L all over G all squared. And this means t squared equal to 2 pi square root of L all over G, 2 pi square root of L all over G. So if we now expand this, we have t squared be equal to 2 pi times 2 times 2 is 4, pi times pi is pi square, and square root of L over G times square root of L over G is L all over G. Remember surds, A times this is equal to A. So root L over G times L over G is this. So by the time you cross multiply, we'll have T squared G equal to 4 pi square L. But our interest here is G. So we can say that G is equal to 4 pi square L all over T squared. So with the length, if we know the length and the period, we can determine G. So we have a problem. A simple pendulum makes 20 oscillations in 57.6 seconds. When the length of the pendulum is shortened by 0.5 meters, the time taken for 20 oscillations is 50.1 seconds. Calculate the original length of the pendulum. That is A part. The B part is determine the value of acceleration due to gravity. So looking at this, we have two scenarios here. The first scenario is that L, the length of the thread is L, and the time is 57.6. And when the length is shortened, maybe L minus 0.5 meters. So these are the two scenarios we have here. So we are going to appeal to the formula T is equal to 2 pi square root of L all over G. So the first instance, before we substitute, I want to explain. T, that is period, in the first instance is 57.6 divided by 20. In the second instance, here T is equal to 57.6 divided by 20. In the second one, where the length is shortened, we have 0.1 divided by 20 oscillations to give us T. So using this, we can say that T, for the first one, we have 57.6 by 20 equal to 2 pi square root of L all over G. And that will be our equation 1. But let's simplify this equation. By the time you divide this, we should have 2.88 equal to square root of L all over G. That's our equation 1. Then in the second scenario, we have 50.1 all over 20 equal to 2 pi square root of L all over G. And our L in this case is L minus 0.5, because that is when the length shortened by 0.5 all over G. So if you now divide 50.1 by 20 will give us 2.51 equal to 2 pi square root of L minus 0.5 all over G. And that will be our equation 2. So by the time we solve the two equations, solving equation 1 and 2, how do we do that? We divide equation 1 by 2. So we now have 2.88 divided by 2.51 equal to 2 pi square root of L all over G divided by 2 pi square root of L minus 0.5 all over G. So if you divide 2.88 by 2.51, we have 1.147 equal to 2 pi square root of L all over G times, remember this is division. So we now have G, we now have, remember this is 2 pi square root of L all over G. Is that right? Square root of L all over G times, in this case, we have G all over 2 pi L minus 0.5. So we have This 2 pi can take care of this. This g will take care of this. I will have 1.147 equal to root L all over L minus 0.5. So, in order to remove this square root sign, we need to square both sides of the equation. And that becomes square both sides of the equation. That becomes 1.147 squared equal to L square root of that all over L. Remember, this is square root. So this should be square root of L minus 0.5 all squared. So by the time we square this, if you square 1.147, we should have 1.316 equal to L all over L minus 0.5. So it becomes easy now for us to solve. By cross multiplication, we have L equal to 1.316 into L minus 0.5. So by the time we do that, we open the bracket, we have L equal to 1.316 L. That is 1.316 times L is this minus 1.316 times 0.5 will give us 0.658. 0.658. So we'll now collect like terms. So we'll have 0.658 equal to 1.316 L minus L. This L is the same thing as 1L. So by the time we subtract 1.316 L minus 1L, this gives us 0.658 equal to 0.316 L. So L now will be equal to 0.658 divided by 0.316. So by the time we do that, we'll have 2.08. So L now will be equal to 2.08 meters. So the next B part of it is to look for acceleration due to gravity. B part of it is G is equal to 4 pi square L all over T square. That is what we derived. Remember, this is a constant. Pi is a constant which has a value of 22/7. We have determined L. And then we have determined the T square. So this is equal to 4 times 3.142 all squared times 2.08 divided by T square. That is 2.8 2.88 squared. So by the time you do that, evaluate all this, G now will be equal to 9.9 meters per second